Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett and we cover all things Gen Chem related on this channel. On this quick video, I'm going to introduce combustion reactions and help you to understand how to predict the products of these types of equations when they occur. Let's get started. We introduced combustion reactions briefly in a few videos before, but now we're just going to delve into what they are and how to actually go about predicting products when these occur. So reactions which involve oxygen gas as one of the reactants are considered to be combustion reactions. Now, these reactions tend to release a lot of energy, and they fall into a subclass of one of the redox type of reactions that we discussed before, because we are actually converting those free elements into these ions. And so shown here is a typical combustion reaction for you, where we have this hydrocarbon, this carbon and hydrogen containing compound reacting with oxygen. Now, notice the product that are being produced. Primarily, when you have hydrocarbons reacting with oxygen, the two products that you're going to see are carbon dioxide and water. And then we adjust the coefficient position accordingly to balance out the equation. So some common products are shown for you here for combustion reactions. Again, combustion reactions, we're reacting some compound with oxygen. Now, each of the elements that's in the other reactant are going to combine with oxygen to form something new. And so, for instance, if the the other reactant contains carbon, we would anticipate that some of the oxygen is going to come with the carbon and create carbon dioxide. If it has hydrogen, some oxygen will create water. If it has sulfur, some of the oxygen will come and can create sulfur dioxide. If there's nitrogen, we're going to be creating nitrogen monoxide or nitrogen dioxide. And then if there's a metal present, then you would be creating the metal with the oxide with the appropriate charges indicated. So if we take an example of this methanol, and we wanted to write an equation for the complete combustion of it. So we have methanol, which is CH3OH. As we're predicting the combustion equation, we would be reacting this with oxygen, and then we're going to refer to what we just saw in that chart. So any carbon that's present in this starting material, methanol, we're going to have some carbon dioxide being formed. And then we also have some hydrogen that's present that will combine with the oxygen to make water. Okay, so predicting the products is actually pretty straightforward, but then we want to make sure that we do indeed balance the equation. And so we can see quickly that we have our imbalance in our in our hydrogens that it's occurring. And remember that our hydrogen is in two places in the methanol example. So we have a total of 4 hydrogens and only 2 in the product side. So now if we adjust the coefficient position to allow us to have 4 hydrogens, that now not only adjusts the hydrogen number, but also the oxygen number on the product side. We have our product side. Now we have 2 over here. We have two oxygens plus 2 more. So 2 and 2 gives us 4, and we have 3 on the other side. And so now if we come in and adjust, well, so now this is where it can get some back and forth may happen, because since we have hydrogen and oxygen in 2 separate places, we're going to have to, not get complacent with the number that we may place down. And so to balance out the oxygens, we may think, okay, let's try putting a 2 here in front of the methanol, because that at least now gives us now 2 oxygens. So 2 oxygens plus 2 gives us 4. But now notice it also has adjusted my hydrogens and my carbons. So if I come in and adjust on the product side for my carbons, I would put a 2 here. Notice that also changes the number of oxygens, but now at least our carbons are settled. But we have to go back to those hydrogens and adjust that one more time. And so with the hydrogens, we see we have 3 plus 1, that gives us 4, times 2 gives us a total of 8 hydrogens. So over here, we would want to put a 4 to balance out those hydrogens. Now in total, what we have for our oxygen count would be 4 plus 4 gives us 8 oxygens that we need to account for. Right now, we have 2 and 2, which gives us only 4. So what we're going to do, we're not going to place a 4 here, because we got to remember we still have that oxygen in the methanol. But instead, we will place a 3, because that will now actually balance out the oxygens, because I now have 6 oxygens plus 2 gives me a total of 8. Okay. And so that would be what we're doing when we're predicting combustion reactions. Take those elements, make the predicted products, and then balance out the equation accordingly. try these last two. So we have the combustion of acetic acid. So again, that's HC2H3O2, and it's combustion. So we're going to add oxygen. We know we're going to create some amount of carbon dioxide for the carbons that are present and some amount of water for the hydrogens that are present. Okay, now we go back to balancing. And again, we have a lot of elements in a lot of different places. So we can see in this one, I may actually just go ahead and list what we have. So we have some hydrogen, we have carbon, we have oxygen. So on the reactant side, I'm starting with 4 total hydrogens, 2 carbons, and 4 oxygens. On the product side, I have 2 hydrogens, 1 carbon, and 3 oxygens. I probably would not start with the oxygens just simply because it's in 2 different places on both sides of the reaction. So that might make it a little bit more difficult to balance things out. And so perhaps we might say, let's start with the hydrogens. Sure. So to balance out our hydrogens, perhaps we'll think about putting a 2 there. That now gives us 4 hydrogens. So that's satisfied. Oxygen-wise, we now have 4, and that looks to be satisfied for now. But notice what's not satisfied is our carbons. So carbons, we have 2 on the reactant, only 1 on the product. So that means we need 2 here, which will satisfy the carbon. But now it has altered the oxygens. So we now have a total of 4 coming from carbon dioxide. 2 more gives us a total of 6. So to balance this out, we would need to add a 2 here, which will now give us 2 times 2 was 4, plus 2 more gives us 6 oxygens. So this will check out. And then last but not least, we have C3H7 isopropyl alcohol plus OH. And this is combusting, so reacting with oxygen. And then we're going to predict carbon dioxide and water are formed. And then we're going to balance. Again, I'm probably just going to go ahead and list things out just to help make sure I'm keeping track of what's where. We have carbon on the product side gives me 3. We have hydrogen on the, carbon on the reactant side, I have 3. On the reactant side, I have 8 hydrogens, 7 plus 1. And oxygens, I have 3 from the 2 plus 1. On the product side, I have 1 carbon. I have 2 hydrogens, and I have 3 oxygens. So oxygen looks like it's settled, but we know it's going to adjust just because of changing the coefficients to satisfy the other 2 elements. So you all may say, let's start with carbon, and I'm fine with that. So carbon, we could put a 3 in the coefficient position here, which would give us 3. Awesome. But now notice our oxygens, we now have 3 times 2 is 6, plus 1 more gives us 7. We're not going to try to adjust just yet. Let's see if things will work out. If we focus on hydrogen, we see hydrogen, I need 8, but I only have 2. So we might think to put a 4 there. So that gives us 4 times 2 gives us 8. So that's great. Now in our oxygen count, we have 3 times 2, which is 6, plus 4 gives us a total of 10. Now, if we look at what we see on the other side, well, on the other side, we see that we have that oxygen by itself. And so if that oxygen remains by itself, with no coefficient in front of it, we'll never be able to actually get a whole number placed with the other oxygen to balance this out. So what I might suggest doing is actually going ahead and doubling the numbers that you've already placed down, and that'll help get rid of that odd functionality. So if we put a 2 here in front of the isopropyl alcohol, well, now that's going to change this to, so what we're going to do is put a 2, a 6, and an 8 instead here. And hopefully this will help us out, figure out what that last number is. So if we double all those coefficients that we've already placed down, now we have a total of 6 carbons on the reactant side, 6 on the product. For our hydrogens, I have 7 plus 1 is 8 times 2 gives me 16 on the reactant side. On the product side, 8 times 2, I get 16. And now let's check our oxygen, see how they fared. So we have 6 times 2, which is 12, plus 8 gives me a total of 20 oxygens. Now, if I look on my reactant side, well, I already have 2 oxygens accounted for here. So that means I need 18 more. To get 18, I would need to do 9 times 2, which will give us 18 plus 2 gives us our 20. And so it's a back and forth process. Again, when you're balancing equations, make sure you have a pencil and not a pen or an eraser like I do on my touch screen, and don't get settled on a particular number. I hope this video helped you understand combustion reactions and how to predict the products. Make sure you guys like, comment, and subscribe, and let me know what other content you would like to see. I'll see you guys in future videos. Talk to you later.